All right, so determining what, oh, you're okay. Determining whether matrices are inverses is what we're doing today. It's a semi-short, simple, but we'll see. So we're going to start off with what's called the identity matrix. So the identity, for any n by n matrix, the multiplicative identity matrix is an n by n, which is also called a square matrix. So if it's an n by n, called a square matrix. Matrix I, or I sub n, with ones along the main diagonal and zeros elsewhere. So if I have a 2 by 2 identity matrix, notice how I have ones along the diagonal and everywhere else are zeros. If I have a 3 by 3 identity matrix, ones along the main diagonal and zeros everywhere else, okay? So today, we are using this right here. If A and B are square matrices and AB equals BA equals the identity matrix, then B is the multiplicative inverse matrix of A. And we will write it as A to the negative 1. Okay, so our goal is to basically, if we find the product of A and B and it equals one of these, then they are inverses of each other. And here we go. How to find it? First, we're going to find the product of the two matrices. If the product matrix equals an identity matrix, then the answer is yes. If the product matrix equals anything else other than, I forgot the word other, other than the answer, other than it, other else, then I don't know. Then the answer is no. So let's start with this one. We have A equals 1, 2, 3, 4, and B equals -2, 1, 3/2, -1/2. So here they are both square matrices. So we know that there's a chance that they are inverses of each other. And so we're going to multiply. So remember, when you're multiplying, that's why we learned multiplication. It's the elements in the row times the elements in the column. So I have 1 times -2 plus 2 times 3/2. Then my next element, 1 times 1 plus 2 times -1/2. I'm going to repeat with the next. So I have 3 times -2 plus 4 times 3/2. I have 3 times 1 plus 4 times -1/2. My goal here is if they are inverses, my end result would be 1, 1, 0, 0. It would be the identity matrix. So I proceed. This gives me -2 plus 3. Let me change colors. So this is -2 plus 3. That equals 1. This is 1 plus -1. That equals 0. This is -6 plus 6. That equals 0. This is 3 plus 2, or not, -2. And that equals 1. And what do I end up with? I end up 1, 0, 0, 1. So what does that mean? That they are inverses. So the answer would be yes. A and B are inverses. Questions, comments so far? Okay.
So, is this just basically what we will be doing?
Yep.
Oh, okay. Thank you.
Mm-hmm. All right, here you go. Give it a shot. Okay, so when you did your found your product, you have 1 times -4 plus 1 times 5. Then you have 1 times 1 plus 1 times -1. You have 5 times -4 plus 4 times 5. And you have 5 times 1 plus 4 times -1. So AB equals, we end up with -4 plus 5. We end up with 1 plus -1. We end up with -20 plus 20. And we end up with 5 plus -4. What does that mean? Yes, they are inverses. Cool? All right. So the only other thing is that you may end up with a 3x3. And with a 3x3, we are still looking for an identity matrix. It's just bigger. That's a horrible drawn version of it, but you get the point. Okay, so we just have more to multiply. So AB equals, and we have 1 times -1 plus 0 times -3 plus 2 times 1. That's one element. I wrote too big. Hold on, y'all. I won't be able to fit it all with how giant I wrote. I'm going to try to write a little smaller. AB equals. So we had 1 times -1 plus 0 times -3 plus 2 times 1. Now we have 1 times -2 plus 0 times -4 plus 2 times 1. And then we have 1 times 2 plus 0 times 5 plus 2 times -1. Okay, remember we talked about once you've completed the first row, the following rows just follow the pattern, right? I'm gonna do it in black. So I'm using -2, 1, and 1. So -2 times -1 plus 1 times -3 plus 1 times 1. -2 times -2 plus 1 times -4 plus 1 times 1. -2 times 2 plus 1 times 5 plus 1 times -1. And then we have -1 times -1 plus 1 times 3, -3 plus 2 times 1. -1 times -2 plus 1 times -4 plus 2 times 1. And last, -1 times 2 plus 1 times 5 plus 2 times -1. And now you evaluate. Okay, so we have, when we're evaluating, we have -1, 0, and 2. That gives me 1. We have -2, 0, and 2. That gives me 0. We have 2, 0, -2. That gives me 0. So far as checking out. And then we keep evaluating. And we have 2, -3, and 1. 2 minus 3 is -1, plus 1 is 0. We have +4, -4, and 1. That gives me 1. We have -4, 5, and -1. That gives me 0. We have 1, -3, 2. That gives me 0. We have 2, -4, 2. That gives me 0. And we have -2, 5, -2. And that gives me what? Gives me 1. So what does this mean? Yes, they are inverses. It's a tedious process, but is it a hard process? No. Okay. Here is yours to practice.